The final example today is calculator active, so you should get your calculator out. At an intersection in Thomasville, Oregon, which is where Thomas lives, cars turn left at the rate L of t equals this function. Cars per hour over the time interval from 0 to 18 hours, and the graph is given here. First thing we should notice is that this is a rate, and so it's going to behave the way that a derivative behaves. And in part A, we're asked to find, to the nearest whole number, the number of cars turning left at the intersection over the time interval 0 to 18. Well, this is how the rate is changing, and we want the total. So what we want is the integral, the accumulated amount from 0 to 18 of L of t dt. At this point, this is entirely a calculator problem. I would recommend that you put it into your calculator, and once you've put it in your calculator, you hit window, you change your window from 0 to 18, and then you do a zoom fit, just to make sure that your graph looks like the graph that they've drawn here. So there's my graph, there's their graph, ta-da, ta-da. All right, once we've gotten to this point, let's do it this way. Let's do a calc fin int from lower limit 0, upper limit 18. Watch the area under the curve. Woo! Whoop! And there's our definite integral. It says to the nearest whole number, so 1658 cars total. Make sure you've got your units. Part B. Part B says traffic engineers will consider turn restrictions when the number of left turns is greater than or equal to 150. Find all values of t for which this is true and compute the average value. Well, here's 150, and just from drawing this graph we can see that the interval is going to be from here to here. So we need to determine those 2 points, and we're going to do that using our calculator. Come back here. Let's put in 150 into the y2, and then graph again. And then do a calc intersect. When you do that, what you're going to arrive at is that our 2 intersections happen at 12.4 hours and at 16.1 hours. So for the first part of part B, our answer is going to be that L of t is greater than or equal to 150 when t is between these 2 numbers approximately. These are not exact, by the way. Well, now we want the average value. And the average on this interval is simply given by finding the size of the interval. That would be 16.1 minus 12.4, and multiplying its reciprocal by the integral from 12.4 to 16.1. And note that this integral right here is not the same integral that we found in this part of the problem. We're going to need to do this one separately. So I would start by doing 16.1 minus 12.4. So the width of the interval is 3.7 hours. What we need to do now is do 1 divided by 3.7 times, and then we're going to fin int the function on the interval from 12.4 to 16.1. And we arrive at this number. And we should bear in mind that this is still 199 cars. It's not cars per hour because we're just looking for the average value of a function that has units cars. So 199 cars. And that concludes today's lesson.